continue on arithmetic. So we have reviewed the addition, subtraction, multiplication. We haven't reviewed division yet because before we review division, we're gonna learn the reciprocals first. So let's first recall from addition. So from addition that we know that 0 is identity for addition. Such that any number plus 0 is the number itself, right? So this is under addition. And we also learned that number 1 is identity for multiplication. Such that we have any number x multiply 1 is this number itself, right? So this is what we learned. Now, if we look at the inverse operation, we already learned about negation, right? If the inverse operation of addition, we have this negation that we just learned. Now, how about the inverse operation for multiplication? Or in other words, do we have a number that multiply x equal to the identity equals to 1? Right, because we just learned that a number add the negation of this number equal to 0, which is identity in addition. Now, do we have a number in multiplication that this number multiply x will equal to the identity in multiplication? So yes, we do have such number, and such number is called the reciprocal. So maybe we can then look at the definition of reciprocal. So for any number x the reciprocal of x, which is written as 1 over x. It's okay if you haven't learned fraction yet, or if you already learned fraction, it is also a fraction of 1 over x, or 1 divided by x. But here, let's just consider this as a whole item, and which is the reciprocal of the notation x. So the reciprocal of x written as 1 over x, such that 1 over x, the reciprocal, times the x itself will equal to 1. So this term is also called the multiplication or multiplicative inverse of x. Inverse of x. So basically these are just notations, but describing under notations on what is the reciprocal of x, and it is just as simple as 1 over x multiply x will equal to 1. Right, so for example, if I have a number 6, what is the reciprocal of number 6? So that will be 1 over 6, because 1 over 6 times 6 equals, if you don't want jump step, it will first equal to 6 over 6, and 6 divided by 6 is 1. So it's equal to 1. So that proves that the number 1 over 6 is the reciprocal of 6. Or maybe let's give another example involves different signs. If x equal to -8, then the reciprocal of this number should also be a negative number, because eventually we want the multiplication, we want the product equals 1, which is positive 1, so which means that both numbers should either be both positive or both negative. So the reciprocal will also be a negative number. And if you just follow the notation, you will see this as well, because if you first written as 1 over x, and your x now is -8, so it's 1 over -8. So you can either written in this way, or in a bit simplified way, it should be -1 over 8. Now let's verify if this is really a reciprocal. So to verify, we multiply the reciprocal back with the number itself. Remember, we learned the signs in multiplications, right? So if it's both negative, negative, it will become positive. One over 8 times 8. Right. Or maybe let me just write one more step to clarify. So it's equal to -1 times 1 over 8 times -1 times 8. And then this 2 -1 becomes +1. So then what left is just 1 over 8 times 8, which equal to 1. This proves that the number 1 over the number the -1 over 8 is the reciprocal of -8. Now we have a special case. Let's see another example. Now you can see that number 1 seems to be a special case in terms of the identity for the multiplication operation, or in terms of the reciprocal. So obviously the number x, if x equal to 1, then 1 over x also equals 1, so that 1 times 1 equal to 1, that means 1 is the reciprocal of itself. Right? 1 is reciprocal of. And this is the only case. For any other number other than 1, it's not the case. And only for number 1, because 1 is the identity of the multiplication, so then it's the only case that a number is a reciprocal of itself. Okay, let's see one last example. What happens to the reciprocal of a reciprocal? So for example, if I have a number x, now instead of looking for the reciprocal of this number, what happens if I want to find the reciprocal of 1 over x? Right, so instead of looking for x, what if we are looking for the reciprocal of 1 over x? Again, we can just start from the definition. The reciprocal of any number, you can either write this into a different notation for simplification, or actually you can just consider or leave it, and just by knowing that this will be considered as one whole term, then the reciprocal is just 1 over this term, right? So either you can write it as 1 over 8, and then it can be substituted back with this original term of 1 over x. Right now, this number is the reciprocal of 1 over x. However, you can still simplify this expression Now, how to simplify? Maybe intuitively you already see that if you flip this x to the top, you will get the answer. But let's again do this step by step just for clarification. So first of all, how to cancel this out or how to simplify this. One helpful method is to first consider that, well, any number multiplied by 1 is the number itself, and any number divided by itself is also equal to 1. So which means this term is equivalent to the second expression, which multiplied by a x over x. So the reason I'm doing this is that now if you reallocate the x terms to the numerator and denominators, you will find that the term on the denominator will then be cancelled out. Or if I'm just writing one more step, the numerator will be 1 times x. Denominator, if I'm just regrouping that together, that's x over x. Right, so it's x over 1. So it's x. Right, so then the reciprocal of 1 over x is x. Right, it's just like you flip over back again. Okay, now let's take a look at division. So again, before we really look into division, let's recall that subtraction can be considered as subtraction can be considered as a combination of addition and negation. Okay, the reason that we recall the subtraction first is trying to show some similarity by understanding the relationship between addition, subtraction, and multiplication and division. So, like for example, for subtraction a minus b, it is equivalent to written as or to calculate as a plus a negation of b, right? So this actually simply link the operation of addition subtraction by the definition of negation. So now you can see that's why we just show the definition of reciprocal before we demonstrate division. So now if we see the relationship between multiplication and the reciprocal, the division can be written as a divided by b can be written as either in a fraction form of a over b, or it's actually also can be written in the multiplication form of a times 1 over b, where 1 over b is the reciprocal of b. Right, so this is the relation between division and multiplication. So now if we go into the definition, so how do we define? So if we let a and b are any numbers and b cannot be 0, we'll go back to this very soon, but b cannot be 0 in this case. Then the quotient a divided by b is defined as a divided by b, or a over b, or a times 1 over b. This is actually just simply rewrite the division as the form of fraction, or as the form of a multiplication of a reciprocal. And I guess here the only thing that might need to draw your attention is that in any case b cannot equal to 0, or the numbers that lies in the denominator of a fraction can never be 0. This should probably be kept in mind throughout the whole course, that in any case your denominator cannot be 0. Okay, so now by seeing the definition of division, then we can learn a couple simplified form of division, or a couple frequently used conclusion of division. So first of all, for example, if I have a 0 divided by any number, it's always equal to 0, right? Because if I'm writing in this format, 0 over x, right? As long as x do not equal to 0, this expression will always give the outcome of 0. And then if I have a same number, a number divided by itself, intuitively, its parentage equal to 1, right? X over x, or in fraction form, x over x equal to 1. And then dividing by 1, if a number is divided by 1, it will equal to this number itself, right? X over, again, in fraction form, x over 1 equal to x. And then dividing into 1, so if a 1 divided by x, that's the reciprocal of x, that is 1 over x. There's no further simplification for this, it's just going to be 1 over x. And then division into negative numbers, or divisions by signs, it is actually very similar to what we just learned. Well, it's actually equivalent to what we just learned in the signs in multiplication. So let's just repeat this again. So if we have a negative number here, a positive number here, then altogether the outcome should be a negative number. So it should be negative x divided by y. Similarly, if I have x divided by negative 1, it should be a negative number of x divided by y. And only if both numbers are negative, then they cancel out each other and becomes a positive number, just x divided by y, right? And of course, if they both positive, it's just another positive outcome. The outcome is just also a positive number. Right, and then lastly, so up to here we showed a lot of similarity between addition, subtraction, and multiplication and divisions, right? But there do have some difference. There do have some conclusions that cannot be extended from multiplication to division. So the most obvious one that you should pay attention is the associative. So basically, commutative and associative do not apply to divisions. right? Remember that for multiplication we have commutative that a times b equal to b as b times a, and then associated in multiplication we have a times b times c equivalent to a times b first and then times c, right? So those are okay in multiplications, but they will not be okay in division. Basically, a divided by b apparently doesn't equal to b divided by a, right? And also, if I have a divided by b divided by c, it's also not going to be equivalent to this associative way, right? So it's probably not that obviously throughout the symbolic format. So let's just give a couple quick examples. Then you will see it right away that they are not equivalent. Like for example, if a equal to 1, b equal to 2, then a divided by b is 1 divided by 2, which is 1 over 2. However, b divided by a would be 2 divided by 1, which is 2. So apparently these two numbers do not equal to each other, so that the commutative rule doesn't apply to division, right? Also, let's also check the associative rule. So if I have a divided by b divided by c, which is 1 divided by 2 divided by 3. Remember the order of operations that we should always operate the expressions within a bracket first. So we leave 1 divided first. 2 divided by 3 is 2 over 3. And then 1 divided by 2 over 3 is 1 over 2 over 3. This is just written in the fraction format, or either you can use the calculator. It will not give you a rounded number, but it still show a decimal number of your results. But if you know fraction, or if you recall that how do we simplify the reciprocal of the reciprocal, we can flip this over, and this is equivalent to 1 over 2 over 3 multiplied by 3 over 3, because the number doesn't change if you multiply by 1. So then the 3 and the 3 can be cancelled out. So it's 1 times 3 over 2 over 3 times 3, and then it's just 3 over 2. Okay, so now let's check the right hand side of associative. Now a divided by b is 1 divided by 2, then c divided by 3. So first of all, inside the brackets, it's 1 over 2, then divided by 3. So it's 1 over 2 times 1 over 3. It's 1 over 6. Again, like if you haven't learned fraction, you can use your calculator to get the decimal results, or if you already know something about fraction, you will know that it will eventually equal to 1 over 6. So obviously this 1 over 6 does not equal to 3 over 2, and this shows as a counter example that the associative rule doesn't apply to divisions. Okay, and the last example, let's show an example that contains a mix of multiplications and divisions, and let's show some small tricks that how can we simplify this expression or simplify your calculation, maybe by converting the divisions into fractions first. So if we want to calculate 20 multiplied 24 multiplied 28 multiplied 32, then divide 10 and divide by 12, divide by 14, divide by 16. So first of all, these numbers are within the bracket. So even though they're multiplying each other, but to the overall expression, they would be, the whole item would be dividing the first item. So we can first converting the division into a fraction or into a multiplication by written as the reciprocal of this whole term. Again, like for example, if we consider this as just one term or one number a, then the reciprocal will be 1 over a, right? So this will be 1 over 10 times 12 times 14 times 60. And then we can simplify this as 20 times 24 times 28 times 32 times 1 over 10 times 1 over 12, 1 over 14 times 1 over 60. Right, this is by knowing that if I have 1 over a times b, it can be written as 1 over a times 1 over b. You can actually prove this by using the definition of division and using the definition of reciprocal. For example, the reciprocal of a times b is equal to 1 over a times b, and then this is the reciprocal of a, and this is the reciprocal of b, and by the associative or commutative rule of multiplication, they will be equivalent to each other because eventually the product will equal to 1. So here, I can leave this for you after class, but you can just use this conclusion over here to first of all simplify this large division. Now, we can quickly observe that 20 is 2 times of 10, 24 is 2 times of 12, 28 is 2 times of 14. So they have common factors, obviously, in pairs. And then how do we regroup them together? Here we can use the associative rule of multiplication, because the reason that I'm converting the division into the multiplication is that in multiplication, you can then take advantage of a commutative rule or associative rule from multiplications to simplify your calculation. So I can move this term together with a number of 20, and then I can move 1 over 12 together with 24, 28 with 1 over 14, and 32 with 1 over 16. And then it will give me much easier expression that this is 2 times 28 divided by 14 is 2, 32 divided by 16 is also 2. So it's 4 times 4, which is 16. So this gives an example of how you solve a complicated expression which has a mix of multiplication and division, and you can convert your division into multiplications of reciprocal to simplify your operations and to take advantage of using the property of commutative and associative of multiplications. So this is the end of the arithmetic lesson.